All right, so when we talk about composition of functions, think of the word composing. So basically, you're going to compose functions. And when we talk about composing functions, that's where you're gonna take one function, you're gonna take a function and place it or put it inside of another. Okay? That is not the same thing as what we did previously with combination of functions. Combination of functions is where you add, subtract, multiply, divide. Nowhere did we put one inside of another. This is different. This is called composition of functions. And so let's kind of look at a review for this, and then we'll look at some examples. So let's suppose you had this function and you had something like this before. So you remember where you had a graph this function. So you took the parent function x squared and you shifted horizontally to the right. Okay. So that right here that you see is a composition of two functions. You're composing two functions here. That's a composition of two functions. Now you may say, well, how is that? I only see one function called f of x. Okay, well look, you see this right here, x minus 5? I can think, you can think of this as a composition of two functions, even though you just see f of x here. See this x minus 5? Think of this as one function itself. So think of this as g of x, which equals x minus 5. So let's go ahead and let x minus 5 be g of x. Okay? And then let's let f of x be x squared. See, f of x is going to be x squared. So if you take x minus 5 and put it into x here, you will get f of x is equal to x minus 5 squared. So basically, and then remember f of x, I'm sorry, x minus 5 is g of x. So this can be written as g of x squared. Okay, so you're taking g of x and you're putting it inside of f of x. That's a composition. So you have this. You have to think of this as f of x, I'm sorry, f of x minus 5. Remember, x minus 5 is g of x is equal to x minus 5 squared. So you're taking x minus 5 and putting into x, which becomes x minus 5 squared. But you can also read this as this now. So here's your new notation. So listen to this notation. It can also read as f of g of x. So that's a notation. So where you're taking one function, g of x, and put it inside of f. So this notation right here is a composition. So that's the notation for composition, where you take one function, put inside of another. It could also be written like this. Now here's something you may not remember seeing. This right here means the same thing as this. Now listen carefully. F, remember I said this is composition, right? You have a function inside of another. A function inside of another. This means put f first. F is first, put f first here. F compose open circle with g at x. F composed with g at x. Don't confuse this. Don't confuse with this. F close circle g at x. This means multiplication. That's multiplication. So by definition, this means f of x times g of x. That's not the same thing. If you see an open circle, that's composition. Composition means this. Multiplication means this. Different things. Composition, multiplication. Different things, different ideas. Okay? All right, so let's look at some definitions you need to remember. Okay, so composition of two functions. Composition of two functions. Number one, f composed with g at x. So this, I'm reading it as f composed with g at x. That's how you read this. By definition, remember that's an open circle, right? So don't think of multiplication. That's not multiplication. By definition, this means f of g of x, just like this. F of g of x. That's how you read this part. F of g of x. So notice that g of x is inside of f. G of x is inside of f. Okay? If it was written this way, g composed with f at x, whatever's listed first goes first. So by that same idea, this is going to be g of f of x. So this time f of x is inside of g. So f of x is inside of g. G of x is inside of f. Okay? It is not difficult. Here's how you use it. You just got to know that open circle's composition, a dot like this, is multiplication. Different things. Okay, so let's look at an example. Okay, suppose that f of x is 3x plus 5 and g of x is 4 minus 5x. Okay? All right, so example number 1. Okay, letter A, let's find this. F composed with g at x. Now here's how you do it. So I know by definition it means this, or one of these. It doesn't matter, just as long as you know that f is listed first. So using our definitions, I know that this means f composed with g at x. So f of g of x. Okay, once you write the definition, here's the next thing you're going to do. You're going to say this. Well, I know g of x, so whatever you deal with the inside first. The inside is g. Here's g right here. Put that here. Put that here. So that becomes f of 4 minus 5x. And then now this looks like something you've had a couple of weeks ago. So now this says I go to my function f this time, which is this. So f of x is 3x plus 5. And wherever I see the variable x, I substitute 4 minus 5x. So this becomes 3 times 4 minus 5x, x plus 5. So 3 times 4 minus 5x plus 5. Before I go on, let's recall what we did. So by definition, composition, open circle composition, by definition, this means f of g of x. F of g of x. The inside, you put that first. That's g of x, so I find g of x as this. Replace this notation with 4 minus 5x, because g of x equals 4 minus 5x. And then, based on what you had a couple of weeks ago, you go to your function f, and wherever you see the variable, you substitute 4 minus 5x. And then you get rid of the parentheses, so you get 12 minus 3 times negative 5x is 15x plus 5, which becomes negative 15x plus 17. So that is f composed with g at x. That's composition. Okay, B, let's look at B. Suppose we want to find g composed with f at x. So this time g is listed first, right? So g is listed first. So by definition, that means g of f of x. G is listed first. So by definition, that's this. Based on our discussion, we do the inside first. So I got to find out f of x. Remember, f of x is this. F of x is 3x plus 5. That's f of x. That's f of x. So that goes inside now. So that's this. So I'm going to replace f of x with this. So that becomes g of 3x plus 5. And now I go to my function g, which is this. Remember, g is this, 4 minus 5x. And this time, where we see the variable x, I'm going to substitute 3x plus 5. So this becomes 4 minus 5 times 3x plus 5. And now I get rid of the parentheses. You got to multiply first before you subtract. So I get 4 minus 15x. A negative 5 times a positive 5 is a negative 25. Combining like terms, I get negative 15x minus 21. And that is g composed with f at x. Okay, letter C. So that's composition. That's composition. Okay, letter C. Suppose you had f composed with g at 2. So just like in a previous topic we talked about, whenever you're evaluating, whenever you're composing at x, your answer is a variable expression. Whenever you're composing at x, your answer is a variable expression. Notice here, I'm composing at a number, so my answer better just be a number. But I got to use the definition. By definition, this is composition, so by definition, f goes first. So it's f of g of 2. So now I got to find out what g of 2 is. Well, to find g of 2, I got to determine what g of x is. Well, remember, g of x is this. I'm going to go ahead and write it out right here. That's g of x. So g of x is 4 minus 5x. And wherever we see the variable x, I'm going to substitute 2. So g of 2 will be 4 minus 5 times 2. So that's 4 minus 10, which is a negative 6. So now this becomes, g of 2 becomes negative 6. And I'm going to find f of negative 6. So I'm finding f of negative 6. So now I got to go to my function f, which is 3x plus 5. And wherever we see the variable this time, I'm going to substitute negative 6. So I get 3 times negative 6 plus 5. So that's negative 18 plus 5, which is a negative 13. So the answer, f composed with g at 2, f composed with g at 2 is going to equal negative 13. All right, that's all you do. Same thing over and over again. That's just knowing these definitions gets you through all of this. Okay, D, let's suppose we had g composed with f at negative 3. G composed with f at negative 3. Well, by definition, remember g is first this time, so by definition this means g of f of negative 3, right? So now I got to find what f of negative 3 is, so you got to do that first. Well, f of x is this, so I'm going to rewrite f of x. So f of x is 3x plus 5. And so where we see the variable x, you're going to substitute negative 3. So I get 3 times negative 3 plus 5. So that's negative 9 plus 5, which is negative 4. So that is, remember, f of negative 3 is negative 4. So now I got to find g of negative 4. So now I go to my function g, which is 4 minus 5x. And wherever we see the variable x, I got to substitute negative 4. So g of negative 4 becomes 4 minus 5 times negative 4. So that's 4 plus 20, which is 24. So that's the answer to this now. So g composed with f at negative 3 is equal to 24. All right, let's look at another example. We still have about 3 minutes. Let me do another one. So let's write this example number 2. Example number 2. So let's suppose for example number 2, I had this. Let's suppose that f of x is equal to 2x squared minus 3x plus 1. G of x is 6x minus 5. All right, so I have those two functions. Part A, find f composed with g at x. F composed with g at x. Well, remember by definition, f is listed first, and that's composition. That's not multiplication. Composition, open circle. So by definition, this means f of g of x. So remember, evaluating at x, right? This says at x, so my answer is going to be variables. In the previous problem, I was evaluating at a number. My answer was a number. I'm composing at a number. My answer is a number. Okay, so I got to do g of x first, the inside first. Well, here's g of x. So I'm going to substitute in place of g of x, I'm going to put this. So this becomes f of 6x minus 5. Well, now this says I go to my function f, which is this, 2x squared minus 3x plus 1. And wherever you see the variable x, and I see it twice, I'm going to substitute 6x minus 5. All right, now be careful with this one because this is quadratic now. So this is going to become 2 times, I see an x, I'm going to substitute 6x minus 5, but I've got to square it. Minus 3 times, I see an x, I'm going to substitute 6x minus 5, and then plus 1. Now be careful, you got to do the exponent first. So go off to the side and figure out what this is right here. So 6x minus 5 times itself. So FOIL, two binomials. 6x times 6x, 36x squared. The outer is a negative 30x. The inner is also a negative 30x. And the last is a positive 25. Combining like terms, this is 36x squared minus 60x plus 25. What I found is only this. But it's just multiplying by 2 now. So you got to say 2 times this trinomial. 36x squared minus 60x plus 25. And now distributing this, I get minus 18x. A negative 3 times a negative 5 is a positive 15, and then plus 1. Distributing to 2 this time, I get 2 times 36x squared, 72x squared. 2 times a negative 60x is a negative 120x. 2 times 25 is 50, and then minus 18x plus 15 plus 1. Combining like terms, I get 72x squared. A negative 120 and a negative 18x, negative 120x and a negative 18x is a negative 138x. 50 plus 15 plus 1 is 66. And so that's the answer for this one. So the answer, f composed with g at x, is 72x squared minus 138x plus 66. So notice that this was a lot more work. That was a lot more work than this one, than these, because both of those were linear. See that? Those are linear. Now we're doing one where one's linear and the other's quadratic. So that's why this one's a lot more work. But be careful here. So you got to square first. You could have easily messed up, so always double check your work. All right, let's do B. Let's suppose in B, I had this for B. Let's suppose you had G composed with F at X. Let's do X. Well, by definition this time, this means G of F of X. Composition. You're composing. You're putting one function inside of another. So I got to find F of X first. So remember, F of X is this quadratic one. It's 2x squared minus 3x plus 1. What that means is that I'm going to replace this notation with this. So this becomes g of 2x squared minus 3x plus 1. And now I got to find this. Well, what that means is I go to my function g, which is this. It's 6x minus 5. And wherever you see the variable x, I'm going to substitute this trinomial. And so this right here becomes 6 times this trinomial, 2x squared minus 3x plus 1, and then minus 5. Distributing, I get 12x squared. 6 times negative 3x is negative 18x, plus 6 minus 5. So I get 12x squared minus 18x, and then 6 and negative 5 is a positive 1. So what I found is that the answer for this right here, g composed with f at x, is equal to this, 12x squared minus 18x plus 1. So notice that one was easier than this one because here you're taking the linear one, g of x is linear, and putting it inside the quadratic one. Here you're taking the quadratic one, putting it inside the linear one. So it was a little bit easier. Let's do one more and then we'll end. So this is letter C. So letter C, let's suppose we had G composed with F at -1. Now, and you see this time you're at a number, right? You're composing at a number, so the answer better be a number. Well, by definition, this means G of F of -1. So I got to find this first. Always do the inside first. I got to find F of -1. Well, remember, to find F of -1, I got to go to F of X. Well, F of X is recall this quadratic, 2x squared minus 3x plus 1. So where you see the variable x, I'm going to substitute -1. So this becomes 2 times -1 squared minus 3 times -1 plus 1. -1 times itself is 1. 1 times 2 is 2. -3 times -1 is a positive 3 plus 1. 2 plus 3 plus 1 is going to be 6. So f of -1 is 6. So that's what this is. This is all I found is this. So now I got to find g of 6. Well, g of 6 means I go to my function g, which is 6x minus 5, and wherever we see the variable x, I'm going to substitute 6. So this becomes 6 times 6 minus 5, 36 minus 5, which is 31. And so the answer for this is 31. So G composed with F at -1 equals 31. Okay, so we did a lot here, and that is composition. So there's a worksheet on composition, and this is on test number 3. So don't miss any points on test 3 from this, because this is not difficult. It's a fairly straightforward process. Okay, so let me go ahead and end this video.